Very good. Welcome to a new iSocial Web video. I'm Luis Fernandez, and in this case we continue with this series of videos of artificial intelligence applied to SEO. We are going to see a very interesting video, I hope you like it, in which we get out a bit of the usual OpenAI and GPT theme, and we are going to see that there are very functional and very useful alternatives for a lot of tasks. In this case we are going to use a transformer model too, different from GPT, but it is completely free, and we can install it directly in Colab and use it from there. For this we are going to use the sentence transformers library, and what we are going to do is a classifier of texts in different languages, a symmetric semantic search that sounds a bit like Chinese, but what it will do is to compare texts in different languages, imagine Spanish and English, and assign to each other those that are more similar semantically. This is something brutal for when we are doing a multi-language migration and we do not have all the posts assigned one by one, or do not read product URLs, or when we are, for example, assigning hreflangs that we are missing and we want to automate the process. Because of course with 40 posts on a blog that we are migrating would be easy, but if we need to migrate 6 blogs on different domains all to a single domain and we want to put the multi-language correctly there, we are complicated to do the manual review. So with this, the truth is that you can do it for free. With a couple of clicks, we have left it totally prepared. So I am going to explain it step by step so that you can execute it, and then, as this is something more complex, once I explained how to use it, and I make a demo for those who want to stay and see a little how it works, I will make a brief explanation. As always, we are going to do it in Colab so that you can use it easily and you can share it. Here you have all the information, comments about it. This script generated by me. You can follow me here on Twitter if you want to see more about it. And we are going to do the usual work. We install the dependencies. I have run everything beforehand, so you do not have to wait. But basically it is standard process. We install the dependencies, in this case the sentence transformers. We import the dependencies. Here we are going to choose the model. In this case this advances very fast. In this case I am using this model for multilingual phrase mini LM LDoc UV2 of the models that this library has available. You can look for it in its documentation. I did a test, a shake in the projects that I have used, and this is the one that has worked best for me so far. This, as always, if a new project comes out and I have to run it, the smartest action, and that does not take anything, is to try other models and see which ones work better. Here you see that it downloads everything. An interesting fact when you do this kind of things is that you can use a cache folder so that if you have to run or install it again, if the session ends, nothing happens. You do not have to wait because you have it already saved, and so it speeds up the process a little. Here I leave a little info of the models that are currently available in case you want to try them. This is the one we have used. And then we do the typical file upload to Colab. In this case I'm going to upload an .es file and an .en file. Here is a small demo. And as you can see, we simply have an example template with the title column, with the title header, and here we have post titles. This is the most classic example that you can use. Here you can use products or even complete texts. Here it depends on the speed of each processing and the number of content you want to use, but what you have to have here is text, identifiable text. In this case we have used titles from the iSocial web blog. You can take a look. They are also YouTube videos that we have uploaded, and as you can see we have them in Spanish and English. We could upload more languages and do the macheo in more languages. Normally you can work only in 2 languages, but we have applied this in up to 7 different languages. In the documentation you can see, for example, that Distilus, you see, uses 15 languages, the most common languages in the world, including Spanish, Italian, German, Chinese, and the one we are using uses more than 50 languages. So do not worry unless you have languages a little strange. Probably it will work with more or less success, because it is true that the stranger languages have been trained with less text and have less precision, but a great work of aids can do. Then we would have these documents that we have uploaded here. You would upload them here correctly. In this case I have called them ESNN for convenience. I recommend you to do it this way. If you change their name, remember to change it here, because here you are going to have to read them. And if the name is different, it will give you an error, and here you can read them in the data frame. We read a data frame, we continue executing everything. This already does not have much relevance since it is something more complex. Here you have a small explanation of how it works. You will go executing everything until arriving at this last cell. In this last cell you simply mark the language. You have to decide first if it is true what language you want to match to whom. For example, in this case we want to assign the posts in English to Spanish. then what we are going to mark here is that our original language here is commented, is title, it is going to be Spanish. Once we have Spanish marked as the original language, if you want to use another language, you change the name. We go to the bottom and select the other content that we want to pass. In this case, the English one, and here we call it data frame, and we put it in so that we put it in the final result. We would execute this, and you can see that it leaves us here. This is very fast because they are 4 posts. It would leave us a bar here, executing. Also, you can go here to the function. We are going to do it a little bit crappy, but we are going to pass the debug mode here. We run it, and you can run it again, and you will see how it runs title by title. And if there is any error, if it stops somewhere, you can see it. You see that it is downloaded automatically. I have downloaded here a couple of demos. I have here included the example of result. If we only include the title, what it will do is to add extra columns. In this case, we have the results in English. We see that it follows the order. It would be how to extract entities from a URL with OpenAI. We have it here, and it macheia it to us as extract entities from a URL with OpenAI. Here in Google, yes, the truth is that it gives a formatting error. This we can adjust it. You have found it sometime. If you put commas or points, it can transform it automatically to a format. You can skip it, then you will have to go to format, number, and you can remove the automatic or put it in format without formatting or number. You have to adjust it there. Here you can see the results that it actually gives you. We have the match score that would be the reliability from 0 to 1, with which this title is assigned to you by this one. That is to say, this title is assigned to you by this one. And then you have other matches. This is useful because many times there are going to be similar things. This in this case is very easy because they are exact translations, but there are times that you are going to work with exact translations or even quite different titles. So to facilitate the work, I always recommend you to make a manual review, especially in those that have a reliability score of less than 0 with 9. You can review. And for example, you see that here it gives us other results. It gives us the main one with 0.938. And then it gives us another one with 0.475 and another one with 0.298. Here the same and here the same. Here we see that it is very clear the whole match here because they were exact translations. But think that in a more complex project this can be complicated. Then this field, at least in the cases that we have used, it is very useful for us to make revisions. And that would be all. Then you can see, for example, in an export of a WordPress, here I have a file that I have used in several languages. Here we have 4 languages. I have deleted the data to not reveal anything, but you see that we have the ID of the post. This would be a case in a WordPress. Here we would have assigned the match in Spanish, that as I have deleted it, it is not finding it, but we would already have the perfect import pal. We see if it is duplicated in case we have duplicate machios. This is here I have pasted it, but it would be a type as in the typical count of Google Sheets. Here we would have the results that we have here of title image, title. The cores here you can see it's already formatted properly. We would have the other matches, and you can see that here there are very similar cases. Here this one has given us 100% reliability, but when we work on blogs that have dozens and dozens and hundreds of contents, you know that there are cannibalizations and there are very similar contents. So in this case you see that the first one has a reliability of 1, but the second one has 0.92 with 5. And I assure you that if we were to go down below and show you the content, there are many that are with reliability 7, and then there is another one with reliability 5 that we would have to keep an eye on. To be sure that it is correct, we see that here we have the type of post, the permalink that I have deleted it, and the publication status. And that's it. You just have to change these lines that I have commented in the video, these small details of text with the languages that you want to change, and it is execute. It works very fast, it is quite optimized, and I hope it is very helpful for those who want to see a little how it works. We stay here before, and we see that we read everything in data frames to then be able to use it, format it well in CSV, add columns. We get all the texts to some lists to pass it to string format easily. And here's the first thing, a little strange. This is simply the top K. What we are going to do, we are going to use it to optimize this a little bit and to mark the number of results that we want to give us in the number of matches. Here we have put that it goes from 3 to, that is to say that it gives us 3 results, and it is going to compare it with the length of the original language. That is to say, it is going to complete it with all our corpus, so to speak. If you want to have more results hitting the other matches, you can simply upload this and it would show you many more results. And here we have the 2 functions that are the heart of the function, which basically what it does is generate embeddings, and it's all explained here. Then we calculate the cosine distance between the 2, and we get the most similar one. You see that down here we generate the corpus. This is basically with the original language. We pass it all. You see that we call here original land titles. We pass it all to embeddings, the embeddings. If you are not so a little bit into the world of NLP and artificial intelligence, are ways of representing words in vectors, in numbers, but that maintain their semantic properties. It's a way of representing words numerically where our goal is that they are shown as vectors, and in theory, semantically similar words are vectors in a similar position in the plane. We're talking about n-dimensional vectors. They're not vectors of x and y simply. That sounds a little bit complex, but well, that's the truth. That is, today basically to implement this you have to call a function and it executes. You don't need to know the technical background of it. And then we have the function match single model that takes the embeddings of our original language, and we are going to compare them with the language we want. In this case, English, if we are going to compare Spanish with English. And here you have the execution of the function. It is going to pass us the text in the language. It also passes it to embedding. And here we are going to make the comparison. This is a little bit of a collaborative way of doing the cosine product that basically measures the distance between those 2 vectors that we have obtained. And as I said, the closest vectors are similarly semantic. So we keep the shorter distance. And here it is already a matter of formatting. We do a score, we do a corpus ID, we format everything. This is in the case that we put debug, this is in the case that we don't. And we return everything, and we return the high match score, that is to say the closest title, the score itself, and other matches. And that would be all. Any questions you have about this? And if you want to go deeper, you know, we have more videos on the channel. You can also follow us on the iSocialWeb blog. And a pleasure. Thanks for your time. See you in the next video.